So now that we brainstormed a little bit about different ways that we could have people share the same network medium without causing too much interference with one another, which is called multiple access, we can look at our first multiple access technology. And that's called frequency division multiple access, or FDMA for short. We just said what multiple access means, and the way that we go about accomplishing that is by dividing the different links by assigning them different frequencies. So each link is going to get a different frequency, or really a band of frequencies, as we will see, in order to divide them accordingly. So really the idea is that if we're having some process occurring over time, so just have this be time, everything that's happening over time, and have this be frequency, we're assigning each person or each link gets a different frequency on which they're going to communicate. So Anna, or whoever's receiving Anna's message, knows what Anna was saying because they'll know and they'll see the message come in at this frequency. And Ben, whoever's receiving Ben's message, will see that come in on Ben's message, and Charlie and Dana accordingly. So the first time that FDMA was used was in that multiple telegraph, where we had a wire, as we would see right here, and then we had different transmitters and receivers. Draw the transmitters on this side. The transmitters could also be over here. Every person could be a transmitter or a receiver depending upon what's currently happening. And the receivers. And so if this is one link, this would get one frequency band. Say this is Anna, and this is whoever's receiving Anna's message. And this is Ben, and this is whoever's receiving Ben's message. This would be on one frequency band, say it's A. And this is on another one. We'll say that's B. So now, what really is a frequency? How do we define that, and how do we understand what it is? Well, time you can't really feel. You can't hear time. You can't really perceive time other than the fact that it happens. And frequency you can actually hear. If you sustain a frequency, you get a pitch. So different musical instruments, as we said before, have different pitches. So FDMA is really analogous to separating amongst pitches, which is what we saw before. But it's separating them enough so that if you're listening in for this frequency over here, that you would never be able to hear this frequency over here because you're only listening in on a select band. And so the way that we perceive and define what a frequency is by this quantity called Hertz. And what a Hertz means is it's looking at a wave, or just some power or some electromagnetic signal. As we can see right here, this would be one signal. And we always draw things as sinusoids because that's the definition. That's really how we define and come about the idea of a frequency, is in terms of a sinusoid. And so this is one sinusoid, and over time, because we have time on this axis down here, we see the level of the wave over time. And then it comes back, and eventually it hits zero again. So it's done one full cycle once it gets back over to here. So we define a Hertz as being one cycle in 1 second. So this wave, we say, has a frequency of 1 Hertz. And that's how we would define it. And then so a frequency of 2 Hertz or 3 Hertz is higher, and that 2 Hertz would mean that we do 2 cycles in 1 second, and 3 Hertz would mean that we do 3 cycles in 1 second. Like this wave right here, we can see it's come up and down 1 time, and then up and down again 2 in 1 second. So we say that this wave would be a frequency of 2 Hertz, and so on and so forth. Now the frequency bands that we look at in terms of communications are very, very much higher than 1 Hertz or 2 Hertz, and very much higher than anything you could ever hear. If you're in the kilohertz range, the human ear has a range up to about somewhere between 12 and 14 kilohertz. And kilo means times 10 to the 3, or 1,000. So 12 kilohertz is 12,000 hertz, which means that this cycle would have to repeat up and down, back again, and so on 12,000 times before we get to 1 second. Very, very fast. Now, on communications, we're speaking of frequencies that are way, way higher than what we can even perceive. And instead of being in the kilohertz range, we're actually in what's called the megahertz range, which is 1,000,000 hertz. So a frequency of 5 megahertz means that the wave repeats 5 million times in 1 second, that it goes up and down. So you can think even faster than this. would have to be doing 5 million times before it gets to 1 second. You can barely ever even think of drawing that out. And so, as we said though, if we look at this frequency axis, it's not simply just one frequency that each of these channels are on. They're actually on a band of frequencies. So in between here and here, that's one channel. In between here and here, that's another channel. In between here and here, that's another channel, and so on. So if we take this axis and rotate it down, remember now we're not talking about time anymore, whereas up here we're looking at time. Now this is frequency on this axis. So just make sure you remember what axis we're speaking of. Suppose we have between 20 and 120 megahertz, or as we said, it's millions of hertz. So this would be 120 million hertz. This is 20 million hertz. So if we wanted to put, say, 5 channels between 20 and 120 megahertz, kind of here we have 4 channels, but suppose we had a 5th one, and we wanted to put 5 of them within this range. It's really a simple math problem to figure out how to divide that up. So at the end over here you have 120 megahertz, and at the beginning you're at 20. So in between that we have 120 minus 20, right? And then if we want to put 5 of those channels in there, we would divide this by 5 to figure out how much each needs to be spaced. And so if we do that division out, we get 20 megahertz. So each of the channels have to be spaced by 20 megahertz in order to put 5 of them in between. So this first one is between 20 and 40. The second one would be between 40 and 60. The third one between 60 and 80, 80 and 100, 100 and 120. And it fits just like a puzzle. So just keep in mind that when we speak of frequency, we're really meaning a frequency band. So that's really the proper term, is that one of these conversations would be between 20 and 40 megahertz. The other one would be between 40 and 60, between 60 and 80, 80 and 100, and so on. And actually, technically, we need some space in between them. So we can't have them intersecting, or else we will have some interference. So the easiest way to understand FDMA is to think about you on your car radio. And if you're turning the dial to switch stations, really what you're doing is you're changing your receiver on your car to listen in for a different frequency. And that's how the radio stations are distinguished, is by what frequency channel they're on. And so if you're on, say, 95.5, and you've probably heard on a radio station before, they'll say, you're now listening to 95.5 WPLJ. What they really are saying is that your receiver is tuned in to listen to the station of 95.5, and we're up in the megahertz range there. So that's really saying that your car radio is listening in for 95.5 megahertz, and it's tuned in to listen to that station. Then there's another station out here, which if you turned your receiver, you would move up, and then you listen in to this next one, and that dial will switch between the channels for you and listen in to what that radio station is currently broadcasting. And so right here we see one radio station, second radio station, and a third radio station.